So now prepare the following on the table. The first is the controller. The second is the breadboard. So the next is the red LED. Next is the yellow LED. Next is the green LED. This is 1K ohms. Okay, so one resistor for one LED. Alright, so the next, get the two wires for the power supply. So I got the white and the black color, the male to male, and red jumper wire for the red LED. So the same, male to male. Next, for the yellow, male to male for the yellow LED, and the last is the green color for the yellow for the green LED. All right, and now here on my pressing application, you can see here it's ready. The controller, we have 3 LEDs, red, yellow, and green, with 3 resistors. All right, I'm gonna start to sketching up with my connection. The other leg is curved, so this means the longer one. So this is the positive and this other one is the negative, right? So there are 2 grounds here. Grounds means the negative, so we can use any of these 2, right? So I will use the one near to 5V. I will connect this to the blue line of my breadboard. So this is the negative line. So as what I've told you, that this part of the breadboard, the dots are connected horizontally, and then the dots at the middle or the center are connected vertically, right? So remember that. So the next is I will connect the 5V to the red line of the breadboard, which is the positive line. Alright, so I'm now connected. So you can see an indicator here, the green highlighted color of the dots. That means they have already the power supply. They're connected to each other, right? There is power running on these 2 lines. All right, so I'm gonna start here. I'm gonna drag this red LED down here. So I will rotate this 180 degrees. So I will connect the resistor to the ground or the negative line of my LED. Connect it to the negative line of the power supply. I will connect it here to the negative line, right? And the positive line of the LED is connected to the pin number 7. I will connect it to number 7, right? So next, now yellow LED. So rotate it 180 degrees, right? So the same, I'll place the resistor to the negative source of the power supply. Then the positive leg of the LED is connected to pin number 6, the digital pin number 6 in the controller. Alright, so the next is I'm gonna drag the green LED here, rotate it. Okay, so the same pattern, connect it to the negative line, and the positive line, connect it to the pin, digital pin number 5. So how many digital pins? 5, 6, and 7, right? So now let's go to our connection. Okay, so please follow me. Right. Okay, I think it's clear already. Alright, go to the controller. The first, I'm gonna pick the white jumper wire. I will connect it to the ground, which is near to 5V, right? So 5V, near to 5 volt. Okay, so I will connect this. Oh no, this is the white wire, so this is supposed to be the 5V. So I will connect this to 5V and then connect it to the red line of the breadboard, alright, the power supply, alright. So the next is the black. It's connected to the ground near to 5V, and then I will connect it to the blue line of the power supply, the breadboard, alright. Okay, so here it is. Okay, so it's clear. And then this one. Alright, so the next is I'm gonna get the red LED first. So remember, the long leg must be connected to pin number 7, right? So here, so get one resistor and connect it here to the negative leg of the LED and connect it to the negative line of the breadboard. Alright, so it's here. So negative line of the breadboard, and the red wire, jumper wire, connected to the positive line of, or the positive leg of the LED. I will connect it to digital pin number 7. Alright, so it's clear. So please follow. Alright, and then the breadboard and the controller here, pin number 7. Right. So the next is the yellow LED. So the same. So put resistor to negative leg of the LED and connect it to the negative line of the power supply. Alright. Okay. And the jumper wire to the positive line of the LED and connect it to the digital number 6 of the microcontroller, of the controller. Right here. It's clear. Alright. Okay, next is the last one, the green LED. So the same, with resistor negative line and connect it to the negative line of the power supply right here, and then connect the jumper wire to digital pin number 5. Right, so there are 3 digital outputs, pin number 5, 6 and 7. Alright, so complete. Alright, so I hope that you can follow me. Alright, so get ready. So the next is we're gonna plug the cable. So plug the other end to your laptop or your desktop computer, and the other end is to the microcontroller. Alright, so this one for the controller, I will plug it here. Alright, so there is a light indicator that you are already connected. Alright, now you are ready now for programming. Okay, so alright, so open your IDE. So okay, there is my IDE, the Arduino. Okay, so this is the default setting, the setup of this editor. So here, I'm gonna start this code here. So in this area, this part, we're gonna input our variable, and here is to initialize the program, or which the process, and here is for the loop or the output. So I, P, and O. So input, process, output. Right. So we're gonna start here, declaring the variable. Right. First, we will make a simple program to light up our LED. All right, so please follow. For example, we're gonna use any term for our variable. You can use your own term for the variable, but if you want, you can follow my variable. So first is int. What we mean by int is integer. So we're gonna declare the variable int for the red LED. So I'm gonna use RD to make it short and easy to type. Alright, so red, which digital connection is red connected to digital number 7. Alright, so do you understand, students? So the red LED is connected to number 7. That is why our variable red LED is given the value of number 7. So next is int yellow, the yellow LED. So I will type only YL, make it short. And then what digital pin is this connected to? This is connected to digital pin number 6. Alright, so they are connected to pin number 6. Okay, so here the yellow connected to number 6 and the red is connected to number 7. Okay, so the next is int or integer variable. What is the next LED is the green color. So green, I will type only GR, make it short. Green, what digital output are we using? The digital output number 5. Alright, so don't forget to put a terminator, the semicolon. Alright, so okay, so we are now connected to using our variable in the program. 7 to the red, 6 to the yellow, and 5 to green. Alright, okay, so it's very clear. So now let's go to initialize the program setup. So we just remember this is the constant or cannot be changed function, the terms and the keywords that we use in this programming editor in our robotics programming. So just start with the serial that begin and the baud rate of 9600 and initialize. The first is pin mode. Make sure that it is capital M. Pin mode, what is the first variable? The red LED. And what we need, input or output? We need output, right? So all capitalized. Pin mode, capital M, and then the variable RD after comma and then output. So RD is from here, right? Okay, so the next is pin mode. Pin mode yellow YL. So the same pattern of code, so you just do it by yourselves. Okay, the next is pin mode GR, and then what we need is output. Alright, so we are done with our initialization. So let's go to loop. So a very simple code to make this light. Okay, alright, start. What is the term or keyword that we gonna use here is digital write. So digital write, what is the first variable is RD, and then what we need is to make it open is high. High is turn on with the value of 1, and low is means to turn off with a value of 0. Okay, so next. So remember, students, there are terms that you need to follow here, like digital write. W is capital, it must be capital, and then high capitalize also. So RD is high. So from initialization we still use the same variable, and then we bring this variable here to make it work in the loop. Right, the next is digital write. The next variable is YL, and then high. Alright, so the next is digital write green GR, which means low, high. Right, okay, and So what we're gonna do now is to make sure that the COM port used is the right one. So how to check it? So make sure that the COM port is not COM1. Go to Tools, and then open the COM port. This one, Tools, the port, and make sure that this is not COM1. Use other port except COM1. COM1 is not the right port to use. COM1 is X, right? So in your computer there might there might 2 or 3 will come out here. Like in mine, I have a lot because I've installed some devices here. So in your computer there might be 2. So one of it is COM1. Do not use COM1. Use the other port except COM1, right? If you have COM3, that's the one you have to use, right? Okay, so do not use COM1. If you, when you check it and you cannot see any COM port here, that means you have to check your cable, pull it out, and then pull it in again, and then you check the COM port, right? So make sure that you use the COM port except COM1, right? Okay, so the next here is when you are ready. So let's have to upload the code. So just check, verify, and compile the code if this is already running, or so debug it first. So how to debug your program? So go here and check. So this will pop up because you haven't saved it yet. So I will click X to close and check if the code is correct, right? So it shows here done compiling, so that means the debugging is done and your code is complete and ready to upload. So to upload the code, go here, click this one, right? So click it, and there is pop up. You just close it and then wait here until this is complete. Alright, so done uploading, and check your device if it is working. So it is now working. Alright, the 3 LED is lighting up, are lighting up. So now how to turn this off, because this is already on. So what we need now is how to turn this off. On, off, on, off. Alright, so to blink the LED. Okay, so just go here and then create a delay, and then just make it 1000 millisecond is equivalent to 1 second. So if you use 500 millisecond, that means 0.5 second. Alright, so I will, to make it faster, I will copy this and make a delay here, 500 millisecond. So now I will change this into low, 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 low. Alright, so okay, so high and then low. So try to upload it. So our delay is 0.5 second or 500 millisecond. Alright, so you look at our device is now blinking. Alright, so okay. Alright, so you check yours if it's working. So this is a simple coding.